Hello students, welcome to the next lecture on the probability and stat. Today we will discuss about solved examples on the covariance. Myself Dr. Garg, working in the School of Mathematics, Thapar Institute, India. Simply contact me over here, or else you can simply follow this link for finding the various video on probability and stat. So let's start with this video. So what we have learned up to so far, we have seen the last lecture related to the properties as well as the what is the covariance and its corresponding property. Now in this lecture we will see how you can find the covariance between the two different kind of the variables. We have seen that if you have to find the covariance between the same value, that is nothing but my variance of the x. So we already described about the variance. So we will discuss all those kinds which are available in the literature, like how you can find the covariance between the two discrete random variable, how you can find the covariance between the two continuous random variable, and how you can find the covariance between the x and y based on these relations are there. So we will describe the three examples related to the discrete, three examples related to the continuous, three examples related to this mix are there. So total we will discuss about the 9 examples in this lecture, so that you will able to understand more clearly. So recall that we will find either you can use this first method, that's the covariance is nothing but the expected value of the x minus deviation from the mean and y minus of here, else we can use this method. So I will try to solve all those examples with the help of this method, which is a simple way. So I will describe the two-step rule. You can simply follow these two-step rule for finding the covariance between the x and y. What is that? What is the two-step is? Step number 1 is you have to find the marginal density function of x and y. That is, if you have the joint density function of x and y, you have to find the marginal of x as well as the marginal of y. How you can find the marginal density function? We all know when you have the discrete random variable, then you have to find the marginal of x, which is nothing but the collection of all those y's. Similarly, marginal of y is nothing but collection of all those x. Similarly, for the continuous, instead of this summation, you have to take the integration of the y and here. Once you find the marginal of x and y, then we are trying to find the step number 2 is find the expected value ex, find the expected value ey, find the expected value xy. How you can find that? That's again very simple. When you are working on the discrete, how you find the mean is e of x is summation of x of, instead of this is nothing but my p of x, marginal of x. Similarly, how you can find the expected value of y, this is nothing but my here. Similarly, for the continuous, expected value of x is integration of x. What is that? This is nothing but my marginal of x, which I found in the step number 1. Since there are the two variable x and y, so that's why there is a double summation. One is with respect to x, second is with respect to y are there. And here this is the joint density function because it consists of the two variables. So let's start with the first type. When you have the discrete random variable, we will describe the three examples for this problem. Here you can see there are the discrete random variables, and you have to prove that whether they are, you have to find x and y have different expectations. Means your target is to prove expected value of y is not equal to expected value of x. Second, prove that they are uncorrelated. We already described in the last lectures what is the uncorrelated means. That is the covariance is my 0. So that is a purpose in this question. So we will start with the step number 1. That is you have to find the marginal of x, marginal of y. So x consists of these three values. So I have written these three values here. Similarly, y consists of the -1, 0 and 1. So that's why written here. How you find the marginal of x? So remember what is the definition is? Collection of all those y's of the joint density function. So when x is -1, you can simply add in the row wise. What will happen? This is a 0.2. The number is 0.2. What is the row wise addition is? This is my 0.6. The row wise addition is my 0.2. You can also check that the sum of these three will be 1. Similarly, how you find the marginal of y? You can add them in the column wise because y is written in this wise b. So this is my 0.2, this is my 0.4, and this is my 0.4. Once you find the marginal of x, then what is the step number 2? You can find the expected value, that is nothing but my x of px. So how you find? This into this, this into this, and this into this. You will get this one. This, and this. You will get answer as a 0. Similarly, you can find the expected value of the y, you will get this again answer as this into this, and here clearly says that expected value of the x is not equal to the expected value of y. It means they have different expectations. Second part is how you can prove that they are uncorrelated. So that means your target is to prove the covariance is 0. So now what is that? This we already computed. This value is already 0. This value we computed that's my 0.2. So the only thing is we need to find the here. How you can do that? So this is my joint. So I can take the first value, this x is my here, corresponding value of y is my -1. When x is -1, y is -1, the probability is my 0. Plus when x is -1, y is my 0, what is the probability is 0.1, plus and so on. So what is the last part is 1, 1 and 0.1 is there. So that is the way of the expected value. So once you will solve, you will get the answer as a 0. So therefore you can substitute this value here. So that is the covariance. This value is my 0, this is my 0, this is 0.2. So the covariance is 0. What is the meaning of that? They are uncorrelated. Look about the second example. So again you have to find the covariance. So it means your target is to find this one here. So we will apply this step number 1. We find the marginal of x. So now x consists of only two values, 0 and 1. Y consists of the two values, -1 and +1. What is the answer of this? So you can add them. So it will be my 4/8. So clearly says that because the sum will be 1, so it is again 4/8. What is the corresponding value of the y? So it will be my 3/8, and the corresponding value of this is my 5/8. Again you can check that the sum of them will be 1. Now you can find the expected value of the x. How you can do that? This into this and this, so that's a half. Similarly for here, this is -3/8 plus 5/8, so the answer is my 2/8, or you can say 1/4. Now you have this value, you have this value. Now we will find the expected value of xy. So what will happen? 0 into -1 of 1/8, 0, 0 of 1 of 3/8, 0, 1 of -1 of 2/8, plus 1 of 1 of 2/8. So what is the answer of this? -2/8 plus 2/8. So the answer is my 0 is there. So once it's a 0, you can substitute the values in the covariance. You will get the covariance as a -1/8. Look at one more example here. Again you have to prove whether they are uncorrelated or not. It means your target is to prove the covariance is 0. So again we will apply the step number 1. We can find the marginal of x. How many values of the x are there? There are the 3 values. How many values of the y? Again there are the 3 values. So we can take the addition and the row wise. So it will be give you the marginal of the x. So it will be 5/16. 2, 4 plus 4, 6/16. 2, 4, 2, 2 and 1. That's a 5/16. Similarly you can add in the column wise. You will get the marginal of x and y. Now you can find the expected value of the x. That is my -5/16, 0 plus 5/16, that's a 0. You can find the marginal expected value of the y. -6/, this is 0, this is 0, again it's a 0 out here. So both the values are my 0. How you can find the expected value? So you can see this into this. So what the first value is my 2/16, -1 of, so this line is 0, that is my 0, this line is 0, is my 0. So only these 4 values are there. So 0 plus 1 -1 of 2/16, 1 -1 of this, so that is -2/16 plus of 2/16. So again answer is my 0 out there. So once E of xy is 0, you can substitute here. You can see, you can find the covariance, it will be 0, hence they are uncorrelated. Now look about the second example. Again we will discuss second type. We will again discuss about the 3 different kinds of the examples related to this. So it means now you can see what is given to you. X and y are 2 independent random variable with a mean and here. So this is given to you. Expected value of x, expected value of y. Standard deviation is my 2, so the variance is my 4. Standard deviation is 3, so variance is 9. Your target is to find the covariance between this and this. So now remember, what you can do is I consider u and v here. So your target is to find the covariance of uv. So I can start from here. So what I can find the EU, I can find the EV, I can find the value of UV. So how you can find the value of EU? So that is the E of this. So what is the expected value of AX plus BY? We all know this is nothing but my here. So I can substitute the value of what is the EX is my 3, EY is my 10. So I can substitute here, this is 15 plus 40, that's my 55. Similarly, what is the E of V? V is my here. So if I take this value, this is E of X minus 1 is outside, E of Y. So E of X is my here, 15 minus 10 is nothing but my 5. How you find the E of UV? So you can multiply them, this is a U, this is a V. So this is the E of 9x square minus 3xy plus 12xy minus of 4y square. So once you can multiply, you will get here. After that, you will simplify, you will get here. Now what is given to you? They are independent. What is the meaning of that? Once they are independent, then what is the value of this? You can simply write this value as EX, EY. So what is the EX? EX is given to you 5, EY is nothing but 10. So this value is given to you 10. How you can find the value of EX square? So how you can find the value of EX square? So we can use the value of the variance. What is the definition of the variance is? EX square minus EX whole square. So what is the value of the E of X square? So variance of X is nothing but my 4. This is a minus, the plus E of X is my 5. So that's a 25. That is my 29. So this is the value of 29. Same we can do for the variance of Y. So I can substitute here, this is a 4 plus 25, you can see it's a 4 plus 25, this is a 29. E of xy we can compute like this way, that is my here 5 into 10 and then so on. So after the calculation you will get the E of UV. So I substitute all this value here, this is 247 minus of 55 and 5, you will get the right answer of problem. Look at the another example. What is given to you? X, Y, Z are uncorrelated. So what is the meaning of the uncorrelated? Means the covariance is my 0. But here there are the 3 X, Y, 3 variables. So it means that they are uncorrelated, means the covariance X, Y 0, Y, Z 0 and X, Z are 0. So X, Y, Z are uncorrelated with mean zeros. What is the meaning of that? It means E of X is 0, mean of the Y is 0, mean of the Z is 0. And standard deviations are 5, 12 and 9. So I can write in terms of the variances are here. Then consider U and V are here. How you can find the covariance? So that means your target is to here. Again we apply the same approach. We can start with the E of U. U is my X plus Y. So E of X and E of Y are 0. So it is a 0. We can find the E of V. So again we can see E of V by 0. We can find the E of UV. So you can simply multiply them. You can separate them. Now what is the value of the E of xy? So they are not independent. So once they are not independent, it means you can't say it is always be equal to this. You can't say. So how you can find the value of the E of xy? So we can apply the covariance definition. So since it is a 0, what is the meaning of that? E of xy minus EX, EY is 0. So EX and EY are my 0. If you substitute here, what is that? This is nothing but 0 multiplied 0 is 0. So therefore E of xy is my 0. So this part is my 0. Similarly, this value is also be 0. This value also be a 0. Because covariance is my 0, so it implies this value is 0 multiplied by 0. How you can find the variance E of y square? So we can start with the definition of the variance. So this is nothing but EY square minus EY whole square. So what is the variance of y? Variance of y is nothing but 144. What is the E of y square? What is the E of y? E of y is my 0. So what is the E of y square? So the answer is my 144. So once you get the E of u and then you can substitute this value, you will get the right answer. Look at the another example. So again you have to find, now it is given to you the correlation. So that is a R. You can write correlation either as a R or as a rho. You have to find the variance of this. This is given to you. Correlation is given to you. variance of x and variance of y are given to you. So let's start with this required task. We can apply this one. So before that we can simply write this value because this is the constant number and the variance of the constant value is my 0. So now I can apply the rule of variance of ax plus by. So remember, variance of ax plus by is a square variance of x plus here this is only when x and y are independent, but here in the given statement they are not stating that they are independent. So it means we have to apply plus of 2ab here. So this is my a is my 2, b, if you compare them, b is my minus 4. So you can substitute the value here, you will get this. So what is the variance of x? Is a 4. Variance of 9. How you find the covariance? Because covariance is not given to you. We can apply the concept of correlation. So we all know the correlation is here. So what is the value of the covariance from here? So r, what is the r is half. So root, what is the variance of 4 multiplied by 9? So 436. So that is my 6. You can see this value is my here. So once you can solve, your right answer is my 112. Look about the third type, that is when you have the continuous random variable. Again we will discuss about the 3 examples so that you may able to understand clearly. So 2 random variable having the PDF is this. So you have to show that they are uncorrelated. So what is that? If I consider this value as a u, this value as a v, then your target is to prove covariance as a 0. Again very simple, but here you can see there is a and b are unknown. So firstly we can find the value of a and b. How you find the value of a and b? So look about that. What is the definition of the PDF? What is the PDF? The PDF means when you have the integration is 1, because it's a continuous random variable. So we can start with the definition of the PDF of it. That is the integration over the domain. This is 1 and over the y is 1. I can substitute this value and after the solving you will get a as half. Similarly, I can substitute this value here. 4b is my outside. This is the y of dy is my 1, and after solving you again get the value of b as here. So that is a and b are my half. So what is the f of x? So once you substitute half, it will be nothing but my 2x when it lies between 0 to 1, and what is the f of y is a 2y. So that is f of x and f of y. Now your simple target is to find the value of u and here. So we can start with here as usual. What is the e of x? So I can open this value ex plus ey. How you can find the expected value? Integration of the x of fx. So fx is my 2x. I can substitute here. I can substitute here as a 2y. So after the integration you can get here. So what is the answer of this? Once you integrate them, you will get as a 1 by 3 plus here is again 1 by 3. Similarly for here you will get 4 by 3. The answer is 0. Now how you find the value of e of uv? You can, when you take x into u into v, you will get here. So you can again, you have to simply integrate x square of fx, x square of this. What is the integration of this? It is nothing but my 1 by 4. This is again 1 by 4. So the answer is my 0. So substitute all these value here. You will get this as 4 by 3. Answer is 0. It means they are uncorrelated. Look about the another example here. Again you have to find the covariance of x and y. Now there is a relation between them. So we apply the 2-step. Find the marginal fx and fy, and that step number 2 is we will find the expected value of x, y and so on. So let's draw the graph of this feasible area to find the marginal. So x is 0, x is 1, y is x. So this coordinate is my 1, 1. So the feasible area is my here. Now once you do this, so how you find the marginal of x? How you take the limits of the y? So in order to take the limits of y, you have to take the vertical strip. What is the value of the y here? 0. What is the value of the y here is x. So it's my 0 to x. Now you can substitute the value of this is my 8xy. Now 8x is constant. You can integrate them. you will get answer as 4xy square. What is the domain of the what is the domain of f(x)? You can integrate them, you will get this value. Sorry, this is my y 0 to x. This is my, because here is y is x, so 0 to x are there. What is the minimum value of x? Is 0, maximum is 1. How you find the marginal density function of y? Collection of all those x. You can take the horizontal strip. What is the horizontal? What is the minimum value of this? Is my, what is the value of the x here? This is y. What is the value of x? Is my 1, so it's a y to 1. So now once you integrate them, you will get this value as 4y of here. Now this is my step number 1. Finally, you can find this expected value of x. What is the domain of this? What is the integration? X is from my 0 to 1. So you can integrate from 0 to 1. For the y is from 0 to 1. So now once how you integrate them? It is nothing but my 4 upon 5. And you can integrate this y square. How you can integrate them? This is y cube by 3. This is y5 upon 5 over the 0. How you find the e of xy? So since it is a two variables, so we can integrate them. How you take the limits are there? So since it consists of the function xy, so we will take the look at the original graph. So what is that? I consider as a y, so you can take the limit on the y-axis. This is 0, this is x, so first limit is my 0 to x. What is the minimum value of the x? Is 0, maximum value of x is my 1, so 0 to 1. I can substitute the value of the fxy. What is the function? Is 8xy here, and then so firstly you can integrate with respect to y, and then you can integrate with respect to x. You will get the answer as 4y. You can substitute this value in this expression, you will get the right answer as this. Look at the last example here. You have to find the covariance between the x and y. Again, since it is a continuous random variable, you firstly draw the graph of the feasible region. X is 0, x is 1, y is 0, y is 1, and x plus y is my 1. So the feasible area is my here. That's fine. So find the marginal of the x and y. You have to take the collection of all those y. So take the vertical strip on the y-axis. What is the value of the y here? 0. What is the value of the y here? This is a 1 minus x. So the limits are my 1 minus x. On the other hand, how you take the if you take the vertical on the x-axis, you take the x-axis limit. What is the x value here? Is 0. What is the value of the x here? Is 1 minus y. So the limits are my here. So now you can substitute the value as 3 times x plus y. You can integrate them, because in this case x is my constant, so you can take either, you can integrate like of this. This is xy plus y square upon 2 over 0 to 1 minus x, or you can integrate like this is a constant, so it's a whole square by 2. After substituting, you will get here. Similarly for this, you can take here, this is a 0, this is 1 minus y over this line. Again, now this is with respect to x, so either you can take with respect to x, this is x square by 2 plus xy from the limit 0 to 1 minus y, or since y is my constant, so it's a x plus whole square and so. Now once you will get the marginal of this, now we can start with the find the expected value of the x and y. Here x, here. How you can solve that? You can simply 3 by 2 is outside, so this is my x, so integration is my x square by 2. This is my x cube, so integration is x4 by 4 over 0 to 1 are there. Similarly, you can solve this. How you find the expected value of the xy? You can take this limit. You firstly on the y-axis, so on the y-axis my 0 to 1 minus x, and outside limit is my x, minimum value is my 0, maximum value is my 1. How you integrate them? So there are the two ways. You firstly integrate with respect to y, and then with respect to x are there. Now how you can solve that? Either, again there are the two methods. You can consider x 1 minus x whole square as a common, so you will get as a x by 2 plus 1 minus x by 3. Now you can simplify it and then open this bracket and so on. Otherwise, you can simply see that this is nothing but the 0 to 1 is a beta function of this. So what is the beta function? If you 3 by 2, the first part, that is x square of this. What is that? If you compare, this is m minus 1 and minus 1. So what is that? Beta function of 3 comma 3 here. Similarly for this part, what is that? This is nothing but my x of 1 minus x cube. So what is that? Again, this is nothing but beta function of 2 comma 4. And how you can open this beta function? You can use this as a gamma here. So gamma function. What is the gamma function of 3? That is nothing but my 2 factorial. Gamma function of 6 is nothing but my 5 factorial. Gamma function of 4 is nothing but my 3 factorial. So after solving, you will get answer as 1 by 10. So substitute all these values in the given covariance, you will get the answer as minus 13 by 1. So this is the way you can solve these covariance examples in a very simple and a two-step rule. I hope you can simply learn the concept behind these problems. We will see in the next class what is the correlation analysis and the various properties associated with them. I hope you can enjoy, and you can like, share and comment this video with your friends. You can share this with your colleagues. Best of luck, students. Happy learning.